I have a house in Florida, and this is my home watcher. There's an issue I'm dealing with there, and he's coordinating. I think he's the one who called the other day, too. But anyway, I encourage you to look at that.
It works on Wikipedia.
I'm sorry?
It works on the Wikipedia page. You search 2C couple.
Oh, well, you can look at it individually and then play with it. You sort of get the sense of if you change the relative phases of the dots, you get its appearance. It's interesting. I tested this before I came in today. It worked fine on my computer, but apparently not on this one. All right. The most famous example of frames of reference is from a Swedish Gestalt psychologist, a guy by the name of Gunnar Johansson, who I was fortunate enough to know. And he was probably the primary investigator, looked more than anybody else on this issue of frames of reference. And he came up with a really famous display, which I will show you in a second. Let's pick on you. Tell me what you see there.
Just a lot of white dots on a black background.
Bunch of white dots on a black background. Now, it's obviously something more than that, or I wouldn't have asked you that stupid question. So let's see what happens once it starts moving. Now you see a person walking. I was for Johansson's 80th birthday, they had a second Festschrift for him. And I was invited to go to that, and he had a party. I guess he was a carpenter before he was a psychologist, and he had this island on a lake outside of Stockholm. And I asked him, I said, how did you come up with this thing? And what he told me was really interesting. He said his granddaughter was visiting him one time and had a ladybug on her finger and was running up to him to show her grandfather the ladybug on her finger. And of course, if you're a geeky perceptual psychologist, right, he was thinking to himself, I see my granddaughter moving relative to the ground. And I see her arms moving relative to her torso. And I see the ladybug moving relative to her finger, right? And so he had the idea, in human motion perception, we not only have a single frame of reference, we can have a whole nested hierarchy of frames of reference. All right? And that's what he set out to demonstrate in this display. Now, if he knew what had happened to this after he died, I think he would roll over in his grave, because now people refer to this, he discovered biological motion. But that was not the point of this thing. The point of this thing was this idea that we perceive motions with a whole hierarchy of nested frames of reference. And this is the original display that set that off. Now let's see if this one works. I'll show you one more. Oh, give me a break.
Maybe click on it.
What's that?
You click on or go up to the search bar and click that little puzzle piece up there.
Which one? This one?
Yeah, with the red on it. I thought it was going to be something.
All right, again, you can get on this site yourself. So the main purpose of this is that, and so this is where that research has actually progressed. So one of the things that people are able to do when they look at point light walkers is they can tell about attributes. For example, whether it's a male or a female. Now, how do you think you do that? Any guesses?
By gait and our mental model
of culturally, like how men and women walk?
Well, how do they walk? What makes them different?
Hips.
No guesses? Yes.
I don't think men and women walk differently. I think they walk the same.
Well, in some sense they walk the same, but in some sense they walk differently. And the reason for it is that, again, on average, women have larger hips than men do. So if you look at the size of the hips relative to the size of the shoulders, so for a guy, he's got big shoulders relative to the hips, right? And women are the opposite way around. Their hips are typically wider than their shoulders are. So as a result, women, you get a sway in the hips. So the demo that I would have shown you if Flash wasn't blocked, is all it does is it has a point light walker showing a walker, and then it just varies the width of the two dots on the hips. And as you make it wider, it looks like a female gait. And as you make it smaller, it looks like a male gait. Actually, it's doing two things. It's simultaneously varying the shoulders and the hip. So wide hip, small shoulder. Now again, this is on average. There's some women who have smaller hips than some men. And there's some women who have bigger shoulders than some men. So people are not perfect at this. They can also make judgment about whether a person's anxious, so all kinds of attributes you can get from point light walkers. But again, the reason that Johansen does this, he wanted to make a point about our seeing motion within nested frames of reference. And to be honest, I don't know that computer vision will solve the motion tracking problem until they tackle that. The problem is the combinatorics gets enormous. If any other point can be a frame of reference for any other point, it's a very large search space. All right, I didn't get to show you my favorite demos. I'm bummed. That's the other thing I'm puzzled by, why some of the Flash files are running and others aren't. They're all of about the same vintage. It's a good thing I'm stopping teaching because I gather Flash is just going away. All right, let's switch gears a bit. Why would this vole choose to color itself that way? If someone walked in here in a clown suit, why would they do that?
Attention.
It's because they want to be noticed. All right? That's what attention is. So if all of a sudden those of you who aren't paying attention would immediately jerk up and see what the hell I was doing. Actually, there's a great demo on this. My wife was in business, worked for J.P. Morgan Chase, and she went to a business conference where a lot of tellers were there, and they were trying to train the tellers on what to do if the bank is being robbed while you're there. All right, so let's say somebody walks in the bank holding a gun. What are you going to look at?
The gun.
The gun. Well, that's a problem. If you're going to identify the robber after the fact, right? And so the way they demonstrated this, I have been tempted to do this as a class demo, but never had the nerve to pull it off. You'll see why in a second. So the demo they did, right? The professor's sitting up, he's got his briefcase on the table, and this guy bursts open into the room, fires 3 shots in the air, runs up, grabs the briefcase, and then runs out. And then the professor talks for a while, and then a pretend cop now brings 4 people into the room for a lineup. And the members of the class are asked, who was the guy you just saw run into the class, shoot a gun, grab the professor's briefcase, and run out? You think they'd be very successful at doing it?
I'm guessing not.
The answer is no. I mean, they're not. They're a little better than chance, but not nearly. People tout, well, eyewitness testimony, I have to be right. Eyewitness testimony is wrong a lot of the time because people are looking at the wrong stuff. Actually, a number of years ago, I was on a murder trial in Columbus. How they put me on a murder jury is incomprehensible. But the defendant should have been really happy that I was on the jury because all the worst things so think of all the reasons why wouldn't you believe eyewitness testimony? What conditions would maybe not be the most reliable in the world?
Nighttime,
It's one.
high stress, or,
That's good.
I don't know.
How about if the witness was drunk?
Yeah, that would help.
And how about if there was a gun present? In this case, all those things were there. So the witness said, right, they got in a big fight at some bar in the East Side, and the witness says he was in the car with his brother and saw the defendant, the witness was walking with his brother, saw the defendant drive up in a car and shoot him. And that was the prosecution's case. But it was 3 o'clock in the morning, everybody had been drinking, there was a lot of anxiety because there was a fight, and there were alcohol. And so about half the jury said, well, why would the witness lie? And about half of them said, yeah, why would the witness lie? And I kept arguing, well, the witness doesn't have to be lying, the witness could be mistaken. And then he also eyewitnessed the color of the car, which the defense could prove was not the color he said it was. So we eventually let him off, but I don't know that would have happened if I were on the jury. The reason I was because what they do in Columbus is they you know what the word voir dire means? They question the jurors to see if they're appropriate to be on the jury. So they bring in 12 jurors and then they have some alternates. And so I was initially the alternate. They voir dire the 12 jurors, but they don't voir dire the alternate. So when they kicked off 2 of the jurors, I was automatically put on. And I was all prepared. I was going to get myself off this jury because I knew they had information about everything, and the defense attorney would go, Mr. Todd, I see you're a professor of psychology. I should watch what I say, and I would respond, not too late. But anyway, they put me on the jury, and I don't know how I got off on this track. Let's move on to attention. So this is William James, one of the most famous psychologists in history. He founded in the United States, I think the first psych lab in the United States. They had a couple in Europe. And he has a very good passage about what attention is, which I'll read for you. Everybody knows what attention is. It is the taking possession of the mind in clear and vivid form of one out of what seems several simultaneous possible objects or trains of thought. Focalization, concentration of consciousness are of its essence. It implies withdrawal from some things in order to deal effectively with others, and is a condition which has a real opposite in the confused, dazed, scattered brain state. The thing that strikes out about that is how beautifully written it is. He was the brother of Henry James, who's a famous American author, and there are a few books in scientific history where you read them today and you go, wow, I wish I could write like that. And James is one of them. And one of the first people in psychology to talk about attention. Now, there are two primary themes when we think about attention. One is as a kind of capacity limitation. All right, so if you want to make fun of somebody's intelligence, you might say, he'd have trouble walking and chewing gum at the same time. All right, so there's some things that are hard to do at the same time, like balancing on one leg and counting backwards by 3. I won't ask any of you to attempt that, but there's some things that are easy to do. All right, and so what capacity limitation is that if the tasks that you're doing require more capacity than you have available, then something's going to suffer. So that's one of the general themes about attention. The other, which I'll focus mostly on in this course, is what's called selective attention or perceptual gating. All right, so if one of you should raise your hand while I'm giving a lecture, what happens? What do I do? So what do I do if someone raises their hand?
Look at them.
I look at them. I ask them,
Yeah.
what's your question? So at that moment, when the hand goes up, my attention is triggered toward that student, right? And I'm temporarily ignoring everybody else. And one of the things they teach public speakers is to make eye contact with the whole room, right? You don't want to give a lecture to one person. You want to talk to the whole room. And so you get feedback from them as to, are they not understanding you or what have you. But sometimes I want to concentrate on one person, and when they raise their hand, that's the trigger. Okay, you got my attention, ask your question. That's a kind of perceptual gating. So I'm consciously selecting some information that's available to me at the moment while I'm neglecting everything else. So let's talk first about capacity limitations, divided attention. Easy for some things, driving and talking. Other things are a bit harder, like patting your head and rubbing your stomach. The last time I used this example, I asked somebody in class to do it and they had no trouble whatsoever. So I won't ask for a demonstration of this. Hard things to do. Trying to solve a math problem in your head while you're driving, probably not a good idea. Texting and driving, is that a capacity limitation or a gating limitation? Now, you can talk and drive, no problem. When you're texting, you're looking at your phone. You're not looking at the road, and that causes problems. Now, one of the interesting things about attention is that some things we do automatically, and I'll show you a couple of examples of this. Do we have any musicians in the classroom? What do you play?
What don't I play is a better question.
What's your best instrument?
Piano.
Piano. And do you have to think about where your fingers are going
Sometimes.
when you're playing a hard piece?
Specifically when I'm learning, yes.
Yeah, but once you've got it learned,
I
no.
don't think about it at all.
What do you play?
Piano, same thing.
Same thing?
Saxophone, same thing.
Same thing. So when you're learning, right, piano, all right, you're playing a chord, well, I need this finger here and this finger here. I mean, it just seems impossible when you first start. Same thing on the guitar, right? I got one finger here, and then you sort of position it with the hand, and in my case, it never went past that. But then, after a while, once you've mastered it, you don't even think about it. All you're thinking about is what you're trying, especially really great guitarists, say someone like Eric Clapton. I saw him interviewed one time, and he doesn't even think about the piece he's playing. He's thinking about how he wants to modulate it. Right? So let's say he's playing some particular song, he wants to emphasize one passage in another. These are the thoughts that are going through his head. And so this is an example of how some tasks can require enormous capacity at first, but then once you've learned and mastered them, you do it effortlessly. And so one of the first people to study this was Liz Spelke. I think this may have been her doctoral thesis. Now, probably later than that. She's one of the most famous developmental psychologists in the world. She trained people to read and understand short passages while writing down words from dictation. All right? And performance of participants improved hugely over 6 weeks of training. Right? So you all know what dictation is? It's sort of a lost skill. We don't do it, but it used to be in the days when you didn't have recording. The boss would, please draft a letter for me. Dear Joe, I enjoyed our visit, and then you have a special notation where you write down literally every word that the guy said, and then draft a letter that has that. Now they do it in different ways. I think that kind of note-taking has gone away. But in any event, dictation is hard. It takes a lot of practice to be able to do it. But what Spelke found that after 6 weeks, subjects could do dictation and at the same time read and understand short passages of text. All right, so with enough practice, you can take two tasks that would seem hard, that both of them eventually become easier. The classic example of this is playing an instrument. And those of you who've gone through that know what that transition is. So this prompted speculation is how can we become so good at difficult tasks? And the idea is that some tasks become automatic with sufficient practice. You hear in sports characters all the time, right? That you don't want to be thinking about how you're swinging the tennis ball. You don't want to be thinking about how you're swinging a bat in baseball. You don't want to be thinking about what are the mechanics I'm using when I'm doing a free throw in basketball. You want that in your motor memory. All right? And how do you get it in your motor memory? You practice, 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 practice. Now, I will give you an example of how some things are automatic and you just can't turn it off. Who shall I pick on this time? Let's pick on you. You want the hard task or the easy task?
You can pick.
I'll let you do them both. All right, I'll tell you what. I have a hypothesis that he's smarter than you are. So I'll pick on you first. All right? What I want you to do is, as fast as you can, read all the words on this slide. As fast as you can, out loud.
Right now?
Right now.
Red, blue, green, yellow, yellow, green, blue, red, yellow, blue.
Okay? So we're going to take the speed at which he was able to do that task as a measure of his intelligence. Probably not a very valid measure. All right, now let's compare that to yours. Since you saw him just do that, what I'd like you to do is to read the color of the ink that the words are printed in as fast as you can.
Green, yellow, red, blue, green, blue, red, yellow, yellow, blue, red, green. Yeah, green.
Nope.
Not nearly as fast, is it?
No.
Now, what made that hard?
Sort of cognitive dissonance between like the meaning of the words and the raw data, the color.
Okay, it's easy for him to focus on the words and ignore the color of the ink. However, you're trained from what, age 5 or 6 to focus on words and automatically get the meaning of words when you see them written on a page. All right? It's an automatic process. You can't, because it's automatic, you can't turn it off. You can turn off paying attention to the color of the ink, but you can't turn off the color of the words. So those two things are interfering, specifically since they each have conflicting responses associated with them. This is called the Stroop effect, named after one of the great names in the history of psychology, J. Ridley Stroop. Right? Imagine living life with that name. And this is a really good example of automated processing that sometimes you just can't turn off. So that gets us to selective attention, or the cocktail party effect. How many of you have been in, what's a problem if you're in a cocktail party?
Loud.
Social
It's loud. How many conversations are there?
Too many.
Too many. Is there anybody in here who's not a native English speaker? What's your native language?
Spanish.
Okay. Your English sounds very good. What age did you move here?
4 years ago.
Oh, 4 years ago.
Yeah.
Do you ever have trouble in a noisy restaurant or a cocktail party?
I've gotten better at it, but at the beginning it was really hard.
Right. Right. So what we have learned to do is to focus our attention on a single speaker and ignore the noise. Now, some stuff gets through. So if somebody calls out your name, right, that pops in and automatically grabs your attention. There are other kinds of things that get through too. Actually, I have a good story about this. I was going to the movies with my wife, must have been, I don't know, 30 years ago. And so I'm chatting with my wife, and all of a sudden I notice she's paying no attention to me. Now, if this had been reversed, she would kick me or something. I'd be really furious, but it's okay for her. So anyway, she's paying no attention to me, and I look at her strangely, and she shoos me away. And finally, we get into the movie, and she explains why she wasn't paying attention to her. She had been caught by the conversation of the couple behind us. Apparently, they were on a first date. They'd met in a local church somewhere, and so this was their first date. And he was telling her about how he'd just gotten out of prison. Not the kind of conversation you want to have on a first date. But anyway, she found that conversation much more interesting than whatever it was I was saying. But that's a good example of things that get through. You know, you hear the word prison, can catch your attention. So some things get through, some things don't. What gets through? Now, the famous way of studying this is there's a technique called shadowing. Let's pick on you. What I'm going to ask you to do is I want you to repeat every word I say as fast as you can do it.
Okay.
Okay, so shadowing
Shadowing
is when you repeat every word I say as fast as you can do it. Now, you're actually pretty good at this.
Thank you.
It's not an easy thing to do, right? All right, so the way these original experiments worked is subjects would put on headphones, and through one ear, say the right ear, they'd get a message, and they had to shadow it just like she did. And then after it was over, they would ask about, well, what happened in the other ear? And most of the time, the subjects were pretty clueless. So they could detect a speaker's voice, speaker's location. These are all the ways that you sort of pick up on a number of features. So listeners seldom notice if the unattended ear contained foreign language or reverse speech. Listeners always notice when speech changed to a pure tone, right? So if you're getting speech in the unattended ear, if all of a sudden it turns to a tone, you'll notice that. Listeners seldom remembered content of unattended speech, even if the word was repeated 35 times in a row. They wouldn't be able to remember the content. So the idea here is that the unattended ear receives practically no processing. At least that was Broadbent's theory. And so the basic idea is you have two sources of information gain access in parallel, and that there's a short sensory buffer, and that in order to be conscious of it, you have to read it out of that buffer, right? And so you can only really attend to one ear at a time. That was his theory. One output is allowed through a filter based on its basic characteristics, while the other remains in the buffer for later processing. Now, there was a very famous experiment by two undergraduates, actually. I forget whether Broadbent was at Oxford or Cambridge, one of them. The undergraduates were, let's say he was, for sake of argument, he's at Oxford, and these two undergraduates are from Cambridge. And they decided they wanted to disprove Broadbent's theory, and so they did the following. In the attended ear, they would have 4 and 7. And in the unattended ear, they'd have Jack, 6, Jill. And in the shadowed speech, the subjects would report Jack and Jill, not Jack, 6, Jill. What that meant is that the content from the unattended ear is actually getting through, right? And so they're trying to make sense of it, and they report it in that way. All right, let's switch over to vision, and let's do an example. I want find somebody in the class with a maroon shirt. Are you feeling a little self-conscious? All right. Find somebody in the class with red hair. All right. This is an example of what's called selective attention. All right. And one of the properties of selective attention is there's sometimes you can do that search really fast and effortlessly. There are other times where it takes a lot of processing in order to achieve it. And it depends on how complex the set of features are that you're searching for. So let's look at a few examples. I want you to holler out for each one of these yes or no, all right? So can you find a red circle? Say yes if there's a red circle there, no if it's not. Oh, I said red circle, just a circle. So that's pretty easy if I gave the instructions properly. Let's do another example. Can you find a circle? Say yes or no.
Yes.
It's pretty easy, right? But notice the difference here is that in this case, we only had 8 distractors. And in this case, we got a lot more than 8, right? So for this particular task, the number of distractors doesn't seem to affect how quickly you're able to detect the target. It happens more or less automatically. Now we're going to look for a red circle.
Yes.
That's pretty easy too. All right, look for an upside down V. Yes or no?
Yes.
That's pretty easy. Let's try it again though. Look for an upside down V.
Yes.
Notice that one took a lot longer. All right, so this is an example of what's referred to as a serial search. Right, so some cases it looks like you process all the items at the same time and the number of items doesn't affect your reaction time. In other cases, you can't do that. You have to actually look at all the individual items before making a decision. Where is it? Oh yeah, it's right there. Now the other thing about these tests is that in the easy cases, it doesn't make a difference whether the target's there or the target's not there, or the difference is relatively small. But in the hard case, you're faster when the target's present than when the target is absent. Anybody think of an idea why that might be the case? Yeah.
If it's absent, you have to look through each individual one as opposed to like however many until you find it.
Right, so in the one case, this is what's referred to as a serial self-terminating search. All right, so when you find it, you stop. Don't have to look any longer. And so if it's not there, you have to look at every item and reaction time is a bit longer. So here we have an example of a feature search. So here we're looking at a color amongst a set of different colors. That's easy. Here we're looking at an orientation among distractors of a different orientation. That's easy. Here we're looking at a color amongst a different color. And for all of these, you get a reaction time function that looks like this. As you vary the set size, there's no increase with the number of items. So you're just as fast to this one as you are to that one. So this is what's referred to as a parallel search. Now this is a little bit harder. This is what's called a conjunction search. So in this case, you're looking for a vertical red bar. You have to attend to two features. Same here. So here's a vertical red bar, vertical red bar, vertical red bar. This is an example of the hard search. So if the items are present, it takes about 5 to 15 milliseconds per item. The bigger the set size is, the longer your reaction time is. And if the item is absent, it takes about 10 to 30 milliseconds per item. And the reason is what you suggested earlier. In the case where the target is present, as soon as you find it, you can stop the search. This is an even harder task, which involves a spatial configuration. So we have each of these involves a red bar and a blue bar, and in this case, the red's vertical and the blue's horizontal. This is a particularly hard search. This takes about 20 to 30 milliseconds per item if the target's present, and 40 to 60 if it's absent. So this is an example of what we refer to as visual search. And again, the evidence for parallel search is that as you change the number of targets, the reaction time is unaffected. And the serial search is when, as you add more items, the subject's response time goes down. So parallel search is efficient, searching for features. Serial self-terminating search, items are examined one after another until the target is found or until all items are checked. And this is an inefficient search. Now, this is I love showing counterexamples. The woman who, Ann Treisman, in the National Academy of Science came up with this theory about feature search and conjunction search back, oh my God, probably in the 70s. And at that time, she was at University of Vancouver, and they had another graduate student in that program, a guy named Jim Enns, who right about the time she was promoting this, came up with a really good counterexample. So notice this thing pops out easily, but not so much down here, which is the odd guy out. I guess it's this one. All right. So there's no single feature, maybe in 3D, I guess the 3D orientation perhaps. But there are some, it's not quite as simple as just looking for one feature versus looking for multiple feature. You can have configuration, and again, this is the whole principle of grouping, right? A configuration of features can form a single whole, which can act like a single feature. I show you one last slide, which is this one. This is a paradigm that was developed by Molly Potter, who's a researcher at MIT, who invented this technique called the rapid serial visual presentation, RSVP. And so what she does is she presents images, 10 milliseconds a pop, and you're watching this stuff and you have to press a button when you see a person. And subjects are really good at this. So the idea that you can attend really quickly to some of these features. This is not a single feature, right? You're looking for a person. And so this looks like it's grabbing your attention. I'll talk a little bit, how about if I quit now, and I'll talk a little bit more about different ways to think about attention when we meet next Tuesday. Any questions about this before I let you go? Yeah?
On the previous slide, can you go back to that, please? So would A be,
A's easy.
A is a parallel search?
A's parallel,
And then B is
B's
serial?
not.
It's serial though, right?
Yeah, this is serial. And so the question is, what's different about these two? Is it doesn't really fit with Treisman's theory. Unless you concoct features as being higher order things like whole objects that are oriented in 3D space, which was not in her original thought process. We'll see this whole object will come back. There's a whole another area of attention called object-based attention that we'll talk to next time that relates to this. Anything else? All right, have a good weekend. I'll see you on Tuesday.